very good morning to all of you, bacho. We are live. We are back on ExamDost. We are back with the ESE Officers Series, Electric Circuit ESE PYQ part number 3. So come on, everybody, join quickly. We are back to solving ESE PYQs based on electrical circuits. So quickly, everybody will join. Come on, everyone. Quickly, everybody join. जल्दी से आ जाओ भाई सारे लोग, फटाफट आ जाइए. चलिए, so without wasting any time, let me get on with the first question. The current in a constant inductive system does not change instantaneously. In constant inductive system, the flux linkage is conserved initially. बताइए. इट इज टेलिंग कि एक इंडक्टर में करंट अचानक से नहीं बदल सकता क्योंकि इनिशियली आपका फ्लक्स लिंकेज कंजर्व्ड होता है, विच इज एब्सोल्युटली करेक्ट एंड द करेक्ट रीजन. तो बेसिकली जब आप ये कहते हैं ना इंडक्टर डज नॉट अलाउ सडन चेंज ऑफ करंट, तो दैट इज बेस्ड ऑन द लॉ ऑफ फ्लक्स कंजर्वेशन. द बेसिक प्रिंसिपल बिहाइंड इट इज लॉ ऑफ फ्लक्स कंजर्वेशन. नेक्स्ट, a unit current impulse is applied to a capacitor of C farad. Instantly insert 1 by 2C joule of energy in it. A unit current impulse has infinite current for 0 duration and encloses a charge of 1 coulomb in it. बोलिए भाई, आप डेल्टा टी करंट लगा रहे हैं. You are applying a current equal to delta T and it is telling that suddenly the energy becomes 1 by 2C. So if IT is delta T, then what is the charge? 1 coulomb. And energy of a capacitor Q square by 2C. So it is correct. That impulse current will provide a 1 coulomb charge due to which energy becomes 1 by 2C. A unit step voltage UT minus 5 is applied to the RL network. The current is given by. The current is given by. Again ESE 2001. The current is given by beta. Initially source is 0, so current is 0. Tau is L by R, 1 second. So I infinity plus 0 minus infinity. Now since source is basically U of t minus 5, because the source is delayed, the output is delayed. That is basically a characteristic of a LTI system, that whatever is the delay in the input, same delay appears in the output. ये एक्चुअली LTI सिस्टम की प्रॉपर्टी है कि अगर इनपुट 5 सेकेंड से डिले होगा तो आउटपुट विल ऑल्सो बी डिलेड बाय 5 सेकेंड. Now the response of a network is kt e to the power 2 alpha t. Alpha is positive. The value of f at which it becomes maximum. I think it should be kt e to the power minus alpha t. So current becomes maximum, so the derivative must be 0. So t is 1 by alpha. This is the response of a critically damped system. ये critically damped system का response है बेटा. The response actually looks like This is basically impulse response of a critically damped system like this. So the current is maximum at T equal to 1 by alpha. Current is maximum at 1 by alpha. Next, I is minus 10 e to the power minus 2t. The voltage of the source Vs is. What is Vs if I am giving you IC minus 10 e to the power minus 2t? बता रहा हूं बेटा, क्रिटिकली डैम्ड का ऐसा ही आता है रिस्पॉन्स, अगर तुमने सेकंड ऑर्डर सर्किट पढ़ा है. C1 plus C2t e to the power minus alpha t. चलिए, लेट मी फर्स्ट कैलकुलेट V. Now what is I1? By KCL. Now apply KVL. Vs equal to I1 di1 by dt plus V. So answer is B. Okay, answer is B. ओवरडैम्प्ड में बेटा दो अलग अलग एक्सपोनेंशियल्स आते हैं. इट्स नॉट अबाउट द शेप, इट्स अबाउट द इक्वेशन. ओवरडैम्प्ड का इक्वेशन होता है C1 e की पावर S1t प्लस C2 e की पावर S2t. बट जब t e की पावर माइनस अल्फा t आता है, दैट इज क्रिटिकली डैम्प्ड. Current at t equal to 0 plus. So it is saying steady state is reached with S open. The circuit is under steady state with S open. I need the current I at t equal to 0 plus. गेट टेस्ट सीरीज पे अभी 30% ऑफ चल रहा है ना बेटा, यूजिंग अंकित ESE. Now see beta, at t equal to 0 minus, okay, what will happen at 0 minus? What will happen at 0 minus? This switch will be open and capacitor will be open. Okay, I need VC. So this entire 2 ampere current will go here. This will be 4 volt. Now apply KVL. So at t equal to 0 plus, we will replace capacitor by a voltage source. This will now become 4 volt. Okay. V by 2. Two ampere. At 0 plus current is 2 ampere. Okay. Answer is 2 ampere. B. चलिए नेक्स्ट. सब्जेक्ट वाइज टेस्ट, पार्ट टेस्ट, मॉक टेस्ट सब कुछ रहेगा भाई उसमें. For the circuit shown in the figure, C is 20 microfarad, V0 is minus 50, dV0 by dt is 500 volt per second. Then what is R? Then what is R? ESE 2002. बोलो भाई what is R? चलिए लेट अस सी बेटा. तो 20 माइक्रो 0.01. ओके. तो माइनस V माइनस IR is 0. V is 50. R is 5 kilo ohm. See. R will be 5 kilo ohm. Next. In the circuit shown in the given figure, the switch is closed at t equal to 0. The current through the capacitor will decrease exponentially with a time constant. Again, ESE 2002. The current will decrease exponentially. पावर की इक्वेशन रीड करके जा सकते हो यार. पावर की इक्वेशन में ज्यादा कुछ करना थोड़ी है. देखो राशिद भाई, ग्रामेटिकल एरर पे तुम चैलेंज करने को कर तो दो, कर तो सकते ही हो, लेकिन मुझे लगता नहीं एक्सेप्ट होगा, क्योंकि टेक्निकल क्वेश्चन में ग्रामेटिकल एरर तो मतलब गेट भी मुश्किल ही कंसीडर करता है, लेट अलोन आरआरबी. बाकी कंसीडर कर ले तो बहुत ही बढ़िया बात है. तो देखिए, शॉर्ट 10 वोल्ट सोर्स, tau equal to RC 1 second. Okay, the answer is 1 second. Next. In the circuit shown in the given figure, the switch is moved from position A to B at t equal to 0. Current through the inductor, this is the inductor, satisfies the following condition. I0 is minus 8, di by dt 3, I infinity is 4. ठीक है. पहली बात तो ये सर्किट गड़बड़ लग रहा है. This question is from ESE 2002. Just a minute, let me verify this. क्योंकि वोल्टेज सोर्स दिखाना चाहिए ना अगर I इंफिनिटी दे रहा है. माइनस प्लस इवन. अब ट्राई करिए. I0 is -8. Switch is being moved from A to B. I need the value of R. इंडक्शन मोटर का एक डाउट था, कौन से टेलीग्राम में डाले हो भाई? गेट वाले टेलीग्राम में, AJ वाले में, किस में डाले हो? ESE अगर करना है बेटा तो ESE के लिए उड़ान बैच लो. ESE हो तो सकता है 1 साल में. बेटा मैं इस पे एक अलग से गाइडेंस सेशन ले लूंगा. अभी ESE के सेशन में मैं कहाँ से RRB वाले स्टूडेंट्स को गाइड कर दूं भाई? प्लांट कैपेसिटी और लोड फैक्टर, मेरे ख्याल से कैपेसिटी फैक्टर और लोड फैक्टर के बारे में बात कर रहा है वो. तो कैपेसिटी फैक्टर में एवरेज बाय कैपेसिटी होता है, लोड फैक्टर में एवरेज बाय मैक्सिमम, और कैपेसिटी और मैक्सिमम का डिफरेंस आपका रिजर्व कैपेसिटी होता है. चलिए लेट मी स्टार्ट बेटा. लेट मी स्टार्ट दिस प्रॉब्लम. चलिए शुरू करते हैं. अब बेटा देखिए, t इक्वल टू 0 माइनस माई स्विच विल बी एट A. ठीक है, स्विच विल बी एट A. इंडक्टर विल बी शॉर्ट सर्किट. करंट ऐसे जाएगा, -E1/3 -8 दे रखा है. ठीक है. Now what will happen is at 0 plus. At 0 plus my switch will be connected to B. ठीक है. At 0 plus switch will be connected to B. Current is -8. So inductor will be replaced by a current source. -8. di by dt is also given. L is 2. It is 6, 3 ampere per second. I infinity is minus E2 by R. That is 4. E2 is minus 4R. Now apply KVL. Minus E2 minus IR minus VL equal to 0. So E2 is minus 4R, 4R minus 8R minus. VL is how much? VL is 6. So R will be 0.5. So R आ गया 0.5. ठीक है. हाँ बेटा, गाइडेंस सेशन में प्लान करता हूं. ईएमएफ का वैल्यू तो बेटा हम ही को निकालना पड़ेगा ना, ये सब कंडीशन से. समझ गए मैंने क्या किया? इन्फिनिटी वाली एक इक्वेशन बना ली, एक वोल्टेज से इक्वेशन बना ली, फिर केवीएल लगा लिया. चलिए नेक्स्ट क्वेश्चन. इन द सर्किट शोन बिलो द इनिशियल वोल्टेज अक्रॉस कैपेसिटर इज 2 वोल्ट. I is the unit step current source. So voltage across the capacitor. What will be the capacitor voltage? Come on. RRB जेई सेकेंड शिफ्ट में री एग्जाम होना चाहिए. अब ये कहां से आ गया भाई? ये तो मैं ताजा ताजा खबर सुन रहा हूं. डी. बख्शी साहब, मैं आपका डाउट एक बार डिटेल में चेक करके बताता हूं. फर्स्ट और सेकंड शिफ्ट के क्वेश्चन सेम है तो उससे क्या फर्क पड़ गया? कितना गैप था जो कि बच्चे तैयार कर लेते आंसर्स. गेट में भी आ जाते हैं यार पैरेलल एग्जाम्स में तो सेम आंसर. 2 वोल्ट. Initial voltage is 2 volt. So this current is 1 ampere, 2 volt initial voltage. So this will be 1 volt. So VC will be 1. Now open current source. Resistance across capacitor is 2 ohm. So tau is RC, 0.5 second. VC is VC infinity. तो 1 plus e to the power minus 2t d आएगा. ओके, अभी यार क्वेश्चंस पे फोकस करते हैं, बाकी बातें बाद में. The capacitor in the circuit as shown below is initially charged to 12 volt with S1 and S2 open. S1 is closed at t equal to 0 while S2 is closed at 3 second. The waveform of capacitor current. Capacitor current is represented by ESE 2003 waveform of capacitor current. चलो देखिए, मैं ही बनवा देता हूं, ये अच्छा क्वेश्चन है. तो अगर देखोगे ना, ट्रांजिएंट से अच्छे क्वेश्चंस आए हुए हैं. There are many good problems from the transient that have been asked in ESE as well. Now, listen to me very carefully. For t greater than 0. First, basically, you have closed this switch and this switch is open. सबसे पहले आपने पहला स्विच क्लोज किया, ये ओपन है. तो दिस इज अ डिस्चार्जिंग. So it will deliver current okay. This will be my current 4e to the power minus t by 3. Now at 3 second, what is capacitor voltage? Because at 3 second we are turning on the other switch. 3 second पे हम दूसरा switch on कर रहे हैं. 4.414. Now, for t greater than 3, so this resistance gets shorted. The initial voltage in this period will be 4.414. This period starts at 3 seconds. What about IC? VC by R. Okay. So that is at t equal to 0, current is 4 ampere. Suddenly after shorting, current is 4.414. So the answer should be A. Initial is 4. At 3 second, current is 4.414. Exponentially decaying. तो आंसर इज ए. ठीक है, आंसर ए आ गया. क्लियर हुआ कैसे करना है? इज दिस क्लियर टू ऑल ऑफ यू? नेक्स्ट क्वेश्चन, ESE 2004. The circuit shown above is in steady state before closing the switch. Current I 0 plus if the switch is closed at t equal to 0. Beta, this PDF is uploaded in the free downloads of our app or the website. Okay, free download section under YouTube lecture PDF. Now, Pradeep, beta, if you are well versed with using the initial and the final condition directly, rather than writing the transient equation, then differentiating it, देन दैट इज अ बेटर अप्रोच ऑलवेज. ग्राफ एक्सप्लेन कर दूं बेटा. देखिए करंट इज एक्सपोनेंशियली डिकेइंग. स्विच ऑन किया, करंट अचानक से हो गया 4.414. ठीक है, 3 सेकंड पे यहां पे करंट देखोगे काफी लो होगा और यहां पे अचानक से हो गया 4.414 क्योंकि रेजिस्टेंस जैसे ही कम हुआ करंट एकदम से शूट कर गया और फिर करंट आगे वापस से एक्सपोनेंशियली डीके कर रहा है रोहन भाई. ओके, so at 3 second if you see here current will be 1.62. But as soon as you close the switch, you are cutting out the 2 ohm resistor. So the current suddenly shoots up. करंट अचानक से शूट कर जाता है. ओके, चलिए. Okay. Now at t equal to 0 minus, my circuit will be under steady state. So inductor will be shorted, capacitor will be open. Okay, so how much current? 4 ampere. Okay, what about the capacitor? Capacitor voltage. Current here is 0. 4 volt. ठीक है, मैंने इस लूप में KVL लगा लिया like this. Now at 0 plus the switch becomes closed. Inductor will be replaced by a current source, capacitor by a voltage source. This switch is closed. 4 by 1, 4 ampere. Okay, so I0 is 0. KCL लगा लो ना, ये 4 by 1 4 हो गया तो I0 is 0. तो आंसर is 0 एम्पियर बी. ठीक है, स्विच से करंट जाएगा 0 एम्पियर. करंट इन द स्विच विल बी 0. Next beta, in the circuit shown, it attains the steady state with the switch S closed. Okay, what is the value of IT if S is opened at t equal to 0? If you open the switch at t equal to 0, what is the value of current? देखें भाई, steady state is achieved with the switch S closed so at t equal to 0 minus switch is closed and circuit is under steady state. Steady state means inductor is shorted. So if my switch is closed, beta, actually this 20 volt current flows like this and this 10 volt current will go like this. So what is I0 minus 0.5 ampere? Okay. Now IT equation I need if the switch is opened. So for t greater than 0, after 0, my switch is open. I'm not saying at 0 plus there is a difference between 0 plus and greater than 0. Greater than 0 means t is variable. It can be 1 second, 2 second, 3 second. 0 plus means immediately after 0. So what is I infinity here? Point 0.6. I infinity 0.6 minus 0.1. So B option. Answer is B. Okay. 0.6 minus 0.1. In the circuit shown below, the steady state is attained with switch open. S is closed at 0. What is the value of current at 0 plus? ठीक है, जब इक्वेशन लिखते हैं तो t ग्रेटर देन 0 माने जनरल टाइम की बात करते हैं. But at 0 plus, it is called as your initial condition. Okay. देखें भाई, switch is closed at 0. So at 0 minus, my switch is open and my circuit will be under steady state. Steady state means capacitor will be open circuit. Okay. So it means 3 ampere current will go like this. This voltage will be 3 volt. Now what about VC? Apply KVL. So VC is basically 3 volt. Okay. Now at t equal to 0 plus, At t equal to 0 plus, this switch is closed. This capacitor voltage is 3. Okay. So this current is I. So I into 1 minus 3 minus I into 1 minus 3. So I equal to 3 ampere. The option. Okay, try the next one. Impulse voltage is applied at t equal to 0 to the RL circuit. I0 minus is 1. What is the expression of IT? What is the expression of IT? You are applying a unit impulse voltage, that is delta T. Now, when the source is a non-standard like delta T, you must always use Laplace. So, Laplace of delta T is 1. How to draw the Laplace equivalent of inductor? It is SL parallel with a current source. Current source is initial current by S, 1 by S. Now I need I. Okay. So what we can do? We can apply source transformation. तो आंसर इज ठीक है. जब नॉन स्टैंडर्ड यूनिट स्टेप ना हो या फिर आपका डीसी सोर्स ना हो, ऑलवेज यूज लैपलास. ऑलवेज यूज लैपलास. In the circuit shown, if Is is ut, what are the initial and the steady state voltage across capacitor? You can say Is is 0. That is no source before t equal to 0. So Vc0 is 0. Capacitor is open, entire Is. Zero volt and 1 volt. Simple question. Next question. In the circuit shown below, the constant current source of value I is switched on at t equal to 0. What are the values of I1 and I2 at t equal to 0 with 0 initial condition? Initial conditions are 0. We need I1 and I2. Initial condition 0 means I1 0 minus is 0 and Vc 0 minus is 0. I1 0 plus is same as I1 0 minus is 0. Therefore, I2 is equal to I. है ना? इस जीरो इनिशियल कंडीशन है तो इंडक्टर का करंट तो जीरो ही रहेगा. तो सारा करंट किससे जाएगा? कैपेसिटर से. ड्यू टू जीरो इनिशियल कंडीशन, इंडक्टर करंट विल नॉट बी चेंजिंग इंस्टेंटली. इट विल बी जीरो. So entire supply current will flow through the capacitor. Next question, beta. In the circuit, the switch is opened at t equal to 0 after having been closed for a long time. What is the current through the 50 ohm resistor? बनाइए इसको. What is the current through the 50 ohm resistor? So beta at t equal to 0 minus, circuit will be under steady state. Okay. If the circuit is under steady state, it means inductor is short circuited. Then what is the initial current? 150 by 50, 3 एम्पीयर. अब ये मत कहना इधर की ब्रांच क्यों नहीं ली. इधर की ब्रांच का करंट सेपरेट है 150 बाय 30, इधर का करंट सेपरेट है 150 बाय 50. The two branches are in parallel, so their currents are separate, 150 by 30 and 150 by 50. Now when switch is open, it becomes the discharging RL circuit. Okay. So now what is R? 10 plus 20 plus 50, 80. So what is tau? L by R, 1 by 160. So current will be 3. So answer is D. 3 e to the power minus 160 t. Next question. At t equal to 0, the switch is thrown from B to A of the circuit. What is the value of V0 plus and I0 plus? V0 plus and I0 plus. Again, very easy question, beta. Zero minus is always steady state. So capacitor is fully charged up to supply voltage. So answer is B. 50 volt and 100 milliampere. Very simple. In a RC series circuit, initially at rest has a step voltage signal. The response Vt across capacitor is 1 minus e to the power minus 3t. Now initial voltage is 3. What is the voltage V for the same step signal? अब ये देखिए इनिशियल वोल्टेज 0 थी तो दिस इज द रिस्पॉन्स. इफ द इनिशियल वोल्टेज इज 3, व्हाट इज द रिस्पॉन्स? So from this response, beta, what I can tell? V infinity so answer is B. Simple. Okay. Steady state is reached with the switch S open. S is closed at 0. What is the value of current I at 0 plus? D. चलिए बेटा, let us see this. At t equal to 0 minus, the switch is open, okay, and due to steady state, capacitor is also open, due to which no current goes out of this loop. This current is 4. So this is 8 volt, 4 into 2. Now at t equal to 0 plus, I have closed the switch. So at 0 plus, switch is closed, capacitor becomes a voltage source. 2i. So I बराबर 4. The current is I equal to 4. Okay. लगता तो है बेटा कि IOCL को अगर गेट से रिक्रूट करना हो तब तक नोटिफिकेशन आ जाता. चलिए. The circuit shown is in steady state with switch S open. The switch is closed at 0. What is the value of VC 0 plus and infinity? 0 plus and infinity. चलो तरुण भाई, अगर मेरे नोट्स से आपको फायदा हुआ, आई एम रियली ग्लैड. चलिए देखें. आज के सेशन में टाइम काफी लगे, सारे सर्किट बेस्ड प्रॉब्लम्स है ना. Now, at t equal to 0 minus, switch is open, circuit is under steady state. So no current here, no current here. The entire 2 ampere will go like this. So this voltage will be 2 volt. Now apply KVL. VC plus 1 into 0. So VC is 2 volt. Okay, this is the initial. T greater than 0 पे switch is closed. Current source becomes shorted. So basically source does not supply any energy to capacitor. जब करंट सोर्स के अक्रॉस आपने शॉर्ट सर्किट कर दिया तो सोर्स डज नॉट सप्लाई एनी एनर्जी टू कैपेसिटर. It becomes a discharging RC circuit. If there is no source, it is discharging RC circuit. So VC infinity is 0. It is 0. So answer is C. 2 volt and 0 volt. भाई देखो ऐसे कट ऑफ बता पाना पॉसिबल नहीं है क्योंकि रीजन बाय रीजन वेरी करती है। बस मैं कहूंगा 100 के ऊपर आदमी सेफ मान सकता है खुद को। नाउ इन द बिलो नेटवर्क S is closed for a long time till steady state is attained. S is opened at 0. What is the value of V at 0 plus and infinity? I need the resistor voltage. Try कीजिए। Start this. S is closed for a long time. So at t equal to 0 minus S is closed. Okay. At 0 minus S is closed. My capacitor will be open. So this 2 ampere current will circulate like this. So this will be 8 volt. Now apply KVL. Now we will talk about 0 plus. At 0 plus, the switch is now open. Switch मेरा open हो गया. Capacitor can be replaced by a voltage source of 8 volt. Okay. Now due to this, these two resistances are in series. So the voltage will be 4 volt. At t equal to 0 plus, it is 4 volt. T tending to infinity. Again steady state. The switch is again open and the circuit is under steady state. So this current will flow like this. 8 volt. So 4 volt and 8 volt. B. 4 volt and 8 volt. Very good, Avijit. Next, time constant of the circuit below. Come on, everyone. What is the time constant? You will short voltage source. So R equivalent will be 2 parallel to 1 ohm. Tau is R equivalent into C. 1 second. B. 1 second. Okay. In the network shown below, it is given that V is 1 volt and dV by dt is minus t, where t is the time after the switch is closed. What is the value of C? C बताइए. I am giving you the capacitor voltage as well as derivative of capacitor voltage. I need to know the value of C. Now, beta, capacitor can be treated like a, or just keep it as it is. The switch is closed. What is capacitor voltage 1? This is my I. C dV by dt is minus 10 C. So 1 volt means 1 ampere here. So half is equal to 1 plus I. Point 0.05 farad. Okay. 0.05 farad. समझे? So basically, based on dV by dt, you can calculate the current of the capacitor. A series RLC circuit is to be connected to AC source Vm sin omega t plus phi. The transient will be absent if the source is connected at, तो इसका आंसर आता है ये. ठीक है, साइन वाले सोर्स के लिए दिस इज द रिजल्ट वेयर द ट्रांजिएंट विल बी एब्सेंट. दिस इज द वैल्यू एट विच ट्रांजिएंट डज नॉट ऑकर. अगर कॉस होता तो पाई बाय 2 प्लस tan इनवर्स ओमेगा एल बाय आर. ठीक है, अगर कॉस होता. A lossy capacitor is represented by a capacitor in a parallel with a resistor. What is quality factor at omega? Quality factor of a lossy capacitor. Lossy capacitor means it is a parallel RC circuit. Parallel RC circuit. For parallel, we do B by G. Okay. Omega CR. The network shown is initially at rest. Initial current I when the switch is closed at 0. Initial current I when the switch is closed at 0. Come on, everybody. What is the initial current I when the switch is closed at 0? Initially relaxed means capacitor is uncharged, inductor is uncharged. Initially relaxed means 10 ampere. Okay, next. The circuit shown below is in steady state. S is closed at 0. What is the value of V and dV by dt? V and dV by dt at 0 plus dV by dt across a capacitor is always determined using capacitor current. कैपेसिटर का dV by dt हमेशा उसके करंट से निकाला जाता है. चलिए भाई, so I will talk about two time t equal to 0 minus and t equal to 0 plus. So at 0 minus my circuit will be under steady state. The switch will be open, capacitor will be open, inductor will be short. Okay. So this 2 ampere will flow like this. 4 volt. So at t equal to 0 plus, now my switch is closed. And also beta inductor current is 2. So now my inductor will be replaced by a current source, capacitor by a voltage source. This switch is closed. So current here is 0. Current here is 2 ampere. How? 4 by 2. So current here is 0. dV by dt is 0. Should be 4 and 0. Very good. Next. Switch was open for a long time and at t equal to 0 it is closed. Final voltage and the time constant. Final voltage and the time constant. So at t tending to infinity, capacitor is open. So what is the voltage across capacitor? That is V10. Once capacitor is open, both the resistor are in series. अगर कैपेसिटर ओपन है तो दोनों सीरीज में आ गए. So what is the voltage across capacitor? The voltage of 10. That is 20 into 10 by 10 plus 10. Now, short 20 volt. What is resistance across capacitor? 10 parallel 10. That is 5K. So tau is RC. So 100 millisecond. 0.1 second. 10 volt and 0.1 second. Okay. Under what condition output will be proportional to dVi by dt? किस सिचुएशन में आउटपुट dVi by dt के प्रोपोर्शनल आता है बोलिए. तो देखिए आप इसको ऐसे लिख सकते हैं. Now if RC is very low, so S in time domain basically represents derivative. So it means C. RC is very very small. समझ में आया? RC अगर बहुत लो है तो आपको डेरिवेटिव मिल जाता है. If RC is very low, I can ignore the denominator. Initial voltage across capacitor of 2 farad is 1. The voltage and charge at 3 seconds after connecting a current source 2 ampere at t equal to 0. If you connect a current source, this is ESE 2019. If you connect a current source 2 ampere at t equal to 0, what is the voltage and the charge? So now I is so at t equal to 0, Vc is 1. T is 2. Now beta, it is not given me the direction of current. Whether the current is charging the capacitor in the same direction as the initial voltage or opposite. करंट की वजह से कैपेसिटर की चार्जिंग सेम डायरेक्शन में हो रही है अपोजिट, ये मुझे बताया नहीं. ओके, so I can take two cases. So it is asking at 3 seconds. So it will be 6, 3, 4. Or I can say if current is opposite, -2. So charge will be 8, charge will be -4. B. तो बी और सी दोनों आंसर पॉसिबल हैं. समझ में आई बात? करंट की डायरेक्शन हमको ये नहीं बताएगी करंट सेम पोलैरिटी से चार्ज कर रहा है या अपोजिट. For the circuit, the switch has been in position A for a long time. At t equal to 0, switch is moved to B. Find the equation for capacitor voltage. Come on. I need the capacitor voltage. So at t equal to 0 minus, my switch is at A. Capacitor will be open due to steady state. So this will be like this. This voltage will also be Vc. (25) for t greater than 0. My switch is actually moved to B. This is a series RC circuit. So Vc infinity is 30. minus 5 e to the power minus t by 2. D. Okay, simple. The answer is D. For the given circuit, initial inductor current and capacitor voltage is 0. When S is closed, what is the value of V and dV by dt? Try this. Value of V and dV by dt at 0 plus. Try it out. चलिए, initial inductor current and the capacitor voltage are 0 and 2. So at t equal to 0 plus, I'll replace capacitor by a voltage source and inductor by a current source. But initial inductor current is 0. So inductor will become open circuit. Okay. Initial inductor current 0 है, तो इंडक्टर एक करंट सोर्स बनता है, तो वो ओपन हो गया. कैपेसिटर वोल्टेज इज 2, so it will become a voltage source of 2. ठीक है. Now V is directly 2. But what about dV by dt? So we can say IC is -8. So dV by dt is -4. 2 and -4. A. यही आ रहा है 2 and -4 A. Very good. चलो next. VC 0 is 25. VC expression. Expression for VC. ESE 2011. So this is a simply discharging RC circuit. Discharging RC circuit. 5 ohm. So VC is initial. डिस्चार्जिंग सर्किट की यही इक्वेशन होती है ना, सिंपल. तो डी. वेरी सिंपल क्वेश्चन, डी स्ट्रेट फॉरवर्ड. 0.2 Henry inductor with initial current of 4 ampere is in parallel with a resistor. What is current at 0.8 millisecond? ESE 2011. चलो बताओ. So this is a discharging RL circuit. Tau is L by R. Answer is, this is 2 millisecond. Next, in the branch network, the switch K is opened at t equal to 0, then dV by dt at 0 plus ESE 2011 again dV by dt at 0 plus. तो आप ये तो मान के चलिए बेटा, इन एवरी ईयर ऑफ ESE you will get multiple question based on transient. Not one, you will get multiple problems. देखिए t equal to 0 minus K is open, steady state, capacitor is open. This is 10,000 volt. एक सेकेंड, ये आपका क्लोज था. So V is 0. Now t equal to 0 plus K open. Now since V0 is 0, capacitor is short circuit. तो 10 एम्पियर गोज थ्रू शॉर्ट सर्किट, है ना। 10 एम्पियर पूरा कैपेसिटर में जाएगा, इज 1 10 वोल्ट पर सेकेंड। कैपेसिटर 1 है तो 10 वोल्ट पर सेकेंड। नेचर ऑफ करंट रिस्पॉन्स, तो बेटा दिस इज अ सेकेंड ऑर्डर सर्किट, सेकेंड ऑर्डर सीरीज आरएलसी। तो अल्फा इज R by 2L, ओमेगा नॉट इज 1 by root LC। अल्फा ग्रेटर देन ओमेगा नॉट, ओवर डैम्प्ड, करंट एट इंफिनिटी विल बी 0। एक सेकेंड, बी। I0 is 0, I infinity is 0 due to inductor, due to capacitor। इन्फिनिटी पे कैपेसिटर ओपन हो जाएगा इसीलिए करंट 0, और स्टार्टिंग में करंट इंडक्टर की वजह से 0 रहेगा, तो आंसर इज बी। Coil of resistance and inductance is connected to a 200 volt DC supply. What is rate of change of current at t equal to 0 plus? ESE 2012. I need di by dt at 0 plus. At t equal to 0 plus, inductor is open. I am assuming that inductor is initially uncharged. मुझे कुछ भी नहीं बताया ना इंडक्टर के रिगार्डिंग, so I am assuming my inductor is initially uncharged. So what is VL? So di by dt 250 ampere per second. Next, the circuit shown below is in steady state for a long time with S open. The switch is closed at 0. Current through R at t equal to 0 will be. स्विच को आपने 0 पे क्लोज किया तो 0 प्लस एक्चुअली होगा, 0 प्लस पे R का करंट बताइए। वन एम्पियर, यस। देखो बेटा, I need to solve for 2 times 0 minus and 0 plus because 0 minus gives me the initial condition. So at 0 minus my switch is open. Now capacitor will be open circuit, inductor will be short circuit. 0 minus is always steady state. Okay. Now, this 3 farad and 6 farad are in series. 3 and 6 farad are in series. And what about IL? 1 ampere. So these are my initial condition. Beta, based on initial condition at 0 plus, we will replace inductor and capacitor by the sources. And at 0 plus, the switch is also closed. Four by 3, 2 by 3. So this voltage is 12. This is 2 by 3. This is 2. So what is I? So answer is 1 ampere. Answer is 1 ampere. Correct? So 1 ampere आ जाएगा. Next. Under steady state, a pure inductor acts as short circuit for DC. Potential drop across inductor is proportional to the rate of change of current. बताइए. बोलो भाई. तो आंसर इज ए. So at steady state, current is constant, so voltage will be 0, therefore short. ठीक है, यही रीजन है कि इंडक्टर को शॉर्ट सर्किट क्यों करते हैं, बिकॉज वोल्टेज बिकम जीरो. वोल्टेज बिकम जीरो. वाई? क्योंकि करंट कांस्टेंट है. ESE 2014, under steady state a pure capacitor acts as a open circuit for direct voltage. Direct voltage माने DC voltage, and the current through capacitor is proportional to the rate of change of voltage. So by same logic, the answer is A. Under steady state, VC is constant. So, ठीक है, same logic. In any network, the current will be considered seen to be consisting of a forced current and a natural current. What is a forced current? Forced current. So answer is A. Forced current is a steady state current and a natural current is a transient current without source. Natural response किसे बोलते हैं? जो initial condition की वजह से आ जाए. Natural response is the response due to initial condition without any source. A coil of resistance 10 ohm inductor 0.8. This we already done. This is repeat. 250. There are no transient in pure resistance circuit because they pure resistive circuit में transient क्यों नहीं आता बेटा? Because they have no stored energy. Transient always occurs in circuit with energy storage element. Initial and final value of this function. Initial and final value of this function. ESE 2014 again. 5n minus infinity B. An ideal current source is connected to the disconnected circuit at 0. Okay. Time constant. What is the time constant? बताइए. What is the time constant? ESE 2015. So R equivalent is this. Two RC. Answer is 2 RC. Very good. Next, transients are caused because load is suddenly connected or disconnected. Yes. Sudden change in applied voltage. Yes. Change in stored energy. नहीं यार, change in stored energy तो अचानक से वैसे भी नहीं हो सकता. तो answer is A. The stored energy cannot suddenly change. Okay, transient will be caused due to change in supply, change in load. Because of change in stored energy. Correct दे रखा है कैसे लेकिन change in stored energy impulse से तो हो सकता है change in stored energy. तो फिर ये डी ही भी ये भी मानना पड़ेगा. Stored energy can change due to impulse input. है ना. impulse से क्या होता है, sudden change आ जाता है. Next, the response of a RC series circuit is given. Q0 is the initial charge, final value of current. Now, how to find final value in Laplace? Answer will be 0. S से मल्टीप्लाई करोगे ना तो 0 आ जाएगा. What should be done to find the initial value of circuit variable in a first order RC series circuit excited by only initial condition? Initial value कैसे निकालोगे RC सर्किट में? RC सर्किट में कोई सोर्स नहीं है, सिर्फ इनिशियल कंडीशन है. How will you find initial value? Replace capacitor by a voltage source. कैपेसिटर को आप ऐसे वोल्टेज सोर्स से रिप्लेस करते हैं विच इज इक्वल टू द इनिशियल वोल्टेज. Which of the following is true for the complete response of any network voltage or current variable for step excitation for a first order circuit? बताइए. Step excitation means DC excitation of a first order circuit. What is the output of any current or voltage this is discharging or transient, this is steady state. तो आंसर इज सी. या तो डिस्चार्जिंग या ट्रांजिएंट वाला आएगा या ट्रांजिएंट प्लस स्टेडी स्टेट. One series RC circuit and other series RL circuit are connected in parallel across AC supply. The circuit exhibits two resonance when L is variable. The circuit has two value of L for which imaginary part of input admittance is 0. बताइए. एक सीरीज आरसी और एक सीरीज आरएल है. दे बोथ आर कनेक्टेड पैरेलल टू द एसी सप्लाई. So it is saying कि there will be two frequency of resonance when L is variable. If your L is variable, there are two frequency of resonance. तो आंसर इज ए. देखिए आप क्या कहेंगे. एडमिटेंस इज this is for RL. तो L will have quadratic equation, करेक्ट ना? L की क्वाड्रेटिक इक्वेशन आएगी तो दो रूट्स यहां पे निकल के आएंगे. देयर विल बी टू रूट्स. In a high quality factor parallel resonant circuit is loaded with a resistance. पैरेलल रेजोनेंट सर्किट में अगर रेजिस्टेंस लगाओगे ESE 2017 सर्किट इंपीडेंस रिड्यूसेस, पैरेलल एलिमेंट Z decreases, resonance frequency remains the same, correct? Bandwidth 1 by RC, R decreases, so bandwidth increases. B. ठीक है, पैरेलल में रेजिस्टेंस लगाने से रेजिस्टेंस घटता है, तो रेजिस्टेंस घटेगा तो बैंडविड्थ विल इंक्रीज. For the circuit as shown, consider S1 has been in position B for a long time and S2 has been open. At 0, S1 moves to A and S2 closes instantly. What is the value of V out? Assume initial charge on C is 0. V out का 0 प्लस पे क्या वैल्यू है? ESE 2018. What is the value of V out at 0 plus? Very easy question beta. What is the value of V out at 0 plus? 0. Because so V out is 0. In the circuit as shown in the figure, switch is closed at 0. The current through the capacitor will decrease exponentially with a time constant of magnitude. What is the time constant? What is the time constant again? ESE 2018. One second. B. Next, coil of resistance and inductance is switched on to a 240 volt supply. Di by dt at t equal to 0 and the magnitude of final steady state current. So now beta at t equal to 0, inductor is uncharged. So inductor is open. So inductor voltage is equal to the supply. So di by dt is 400. Di by dt is 400. When angular frequency of DC source is 0, capacitor and inductor will act like ESE 2022. Capacitor and inductor will act like for DC where omega is 0. Capacitor open, inductor short. Okay. The time constant of a RL circuit may be defined as the time at which the current rises to. What is the definition of time constant? Come on everybody, what is the definition? Current rises to 63.2% of initial value. Transient disturbance is produced in a circuit whenever. Transient disturbance, ESE 2022. When are the transient produced? When circuit is suddenly connected or disconnected from the supply. In the circuit of the figure, ESE 2023, circuit of the figure, source voltage is 100, resistance 10K, capacitance 0.005. In how much time can the capacitor be discharged to 5 volt when the switch is turned to position 3? ESE 2023, it means initially switch is at, so VC is equal to E 100 volt. Now switch at 3. So this is discharging RC. Okay. Ten to the power 4, 5 into 10 की power minus 9. Ln 20, 149, 150 माइक्रोसेकंड, 150 माइक्रो आ रहा है यार, तो डी, ठीक है, 150 माइक्रोसेकंड. For the given circuit, supply frequency omega is 2 radian per second, V2 is 2 angle 0. What is value of VL, lead angle of VL with respect to V2? तो बेटा at omega equal to 2, ठीक है, X is 1. अब देखो, this is IR, this is IC. तो ESE 2009 का क्वेश्चन है, V2 is my 2 angle 0. तो V2 I am taking as reference. Now IR will be in same phase, resistance current same phase में आता है. This is a good question. Capacitor current leads, so IR will be so same magnitude but angle is 90. So now beta both are 2. Both are 2. दोनों इक्वल है, 90 डिग्री पे हैं. तो रिजल्टेंट IL, IL will be at 45 degree. Now inductor voltage leads inductor current by 90 degree. ठीक है, तो VL and V2 angle is 135. ये निकाल पाए? 60 प्रॉब्लम विदाउट कैलकुलेटर. विदाउट कैलकुलेटर तो नहीं होगी, बस हम ये कह सकते हैं माइक्रो में आएगा और आंसर माइक्रो में दो दे रखे हैं, 50 और 150, बट 50 से ज्यादा ही आएगा ना. दिस विल बी हायर देन 50, सो आंसर विल बी डी. 50 तो टाउ है ना, 50 तो फिर टाउ से तो ज्यादा ही आ रहा है. If the current leads the applied voltage by tan inverse 2, what is the value of R? करंट लीड कर रहा है. I leads V means capacitor dominates. ओके, निकालिए. So this will be J4. XC minus XL by R. A. 0.5. ठीक है. Next, for AC circuit, RMS voltage of resistor is 120. What is inductor? How much is the inductor value? What is the value of L? Come on, everyone. This is a series circuit. So current is the reference. So resistance voltage is 120. Inductor voltage will lead the resistance by 90 degree or lead the current by 90 degree. The total is 150. RMS की बात करो, total is 150. $90. XL is VL by 3 by 4, 3000 by 4, 750 ohm. Omega is 500, so 1.5 Henry. D. ठीक है. Next, the transfer impedance of a two-port network ESE 2010 remain constant when the position of excitation and response are interchanged. If the network is linear, bilateral, this is reciprocity. Reciprocity. ट्रांसफर इंपिडेंस सेम आने का मतलब है नेटवर्क इज रेसिप्रोकल. तो अ लीनियर बाइलेटरल नेटवर्क इज रेसिप्रोकल. लास्ट क्वेश्चन. अ लोड इज कनेक्टेड टू अ एक्टिव नेटवर्क. आरटीएच वीटीएच इज गिवन. मैक्सिमम पावर बता दो. इस टाइप के कल बहुत सारे क्वेश्चन कराए. व्हाट इज द मैक्सिमम पावर? VTH square by 4 RTH to be 90 watt. ठीक है. तो दैट्स इट बच्चों. इसके बाद अब अपनी मुलाकात होगी मंडे को. ठीक है. मंडे वी आर गोइंग टू डिस्कस अगेन सर्किट एनालिसिस. तो सर्किट एनालिसिस विल बी ओवर बाय वेंसडे, आफ्टर विच वी विल मूव ऑन टू मशीन्स. वेंसडे खत्म करके ना मशीन्स करेंगे फिर. ओके. इज दैट क्लियर टू ऑल ऑफ यू? So I'll see you all on Monday. Thank you.